Right, so today we're going to be looking at computer control. So this is programming and how we make our electronic circuits do what we want. So this specification we're going to be looking at input, process, output, which we look at with every topic in technology. So we're going to describe and analyze computer control systems with reference to input, process, output. So what starts it, what's the process, and what happens at the end. Identify and give examples of computer control applications, easy enough. Flowcharts, so demonstrate a knowledge and understanding of flowcharts. That is handy enough when I go through it here. And draw and name flowchart diagrams to describe a sequence of events. I'm looking at the different commands, so start, stop, output, decision, wait, and feedback loops. So your computer control is basically just programming. So just done you out basically a flowchart to show you and tell you exactly what it is. So it's an organized list of instructions written to perform specific tasks on a computer, or well, it is on the computer. You make it up on the computer and then you put it into your electronic product. It must be clear and precise. Program is the output or a goal of programming, and programs make most things operate effectively. So, input, process, output. Digital control systems use program or series of commands to control the system's functioning. These are used along with everything in electronics. As you know, your computers, your TVs, phones, anything that works has a program or a code inside it. This is just simple coding. It's so we don't have to write in binary or write in special figures. It is easy coding, so it helps us work. Input is what starts the process, you know that. In computer control, there is only one command. That is your start command, so it starts everything off. Everything else is a process, even though it may say input on the commands. It is not an input. Well, technically it is an input, but I would always class it as a process, because you have to always use start first, which starts your program. So process then is how the system works, what allows the output to work. There are a number of different commands, and then your output is a result of what happens, and there are a number of different commands for them. So applications used everywhere. We use programs to make computers, alarms, phones, most electronic products function. In GCSE, so next year, you'll be using this to program the circuit you have made. So next year we get a topic, we get a project that we have to make and stick to, and you'll all be making individual circuits, and then you'll be programming them to do what you want. So we will be programming your circuit to do exactly what you want it to. So your flowcharts. Flowcharts are designed to help you program a circuit without coding. Start and stop commands are the begin and end of every circuit. Outputs will be any component that your PIC chip, so a PIC chip is your wee computer that's basically inside your electronics. So in your circuits next year, you will all have a PIC chip. That is the brain that's in it. Outputs will be any component that your PIC controls, so your LEDs, motors, piezo sounders, buzzers, anything like that. Outputs can be high or low. It's just the type of frequency, the type of voltage and current that you need to go through to it. Waits and pauses are processing commands. These commands use data and variables to control the circuit. So basically a wait or a pause, you put them in and it'll pause between each process. And your decision boxes are inputs from a digital input, so a switch, or an analog input, which is your sensors. And these are the only symbols that you need to know for your GCSE. Do you know the way we've been drawing our electronic symbols and our pneumatic symbols and all? These are what you need for a flowchart, and they have them in the exam. I will be going over how to draw flowcharts with you. It is a bit more complicated, but I just want you to get the basics done and do the basic questions that I've asked you, that you will be doing after this PowerPoint today. You need to know the shapes. You need to be able to draw all these shapes and make sure they are them shapes, otherwise you will lose marks. That's all for computer programming. It was a wee short topic, but it is more difficult when you go to start drawing and stuff and start looking at your programs, and it will obviously be easier when we have the computers to be able to program ourselves. If obviously we're in the classroom, we'd be doing this. I'll probably do a video of me programming a circuit for you or showing you programs next week.